9.1 polar coordinates. So this is just at the top of the page. I have a quick just review of rectangular coordinate system. So with the rectangular coordinate system, we have an x coordinate. So we go across for x, and then we go up for y, and then we plot our point. And all the points are x, y. So in a polar coordinate system, what we do is we have an angle that we graph theta, and then after we graph that angle, we move up our units for our radius, and we write that as r comma theta. So it is kind of weird because we do graph the theta part first and then the r, and it's written r theta. Instead of an origin, we have a pole. Instead of an x-axis, we have a polar axis. But this r theta thing, because of the way we've been graphing angles anyway, should be kind of familiar. So we're going to just start out by graphing. So the first one is 1 comma 200 degrees, and that's going to be S. So I want to think about how this is my polar axis, where I'm starting from. So 200, and sometimes I even write an XY coordinate plane because I'm trying to kind of think about where that would be at. 200 we know would be more than 180 degrees. And so I want to think about how all the way to here would be 180, 200 would be a little bit past that. So I'm going to call this my 200 degrees. And then we're going to be 1 unit out on that line. So that's basically kind of how I'm graphing this. Sometimes you'll see them extend this line, sometimes they won't. I usually don't extend that little part of the line just because then I get confused about what I'm doing. But you graph an angle, and then I should label this part 1 as well. And so this is going to be S. So I went 200 degrees, and then I went out 1 unit from that 0. So on the second one for -2 comma 3 pi over 2. So let's think about 3 pi over 2 would be like 270 degrees. So here's my polar axis. So this would be like the 90, the 180. This would be the 370, or 270, sorry. And so this is 3 pi over 2. And then along that line, I want to go -2. So instead of going in the direction that I'm already in, I'm going to go backwards. And this will be 1, and this will be 2. And so this is -2, because instead of counting from the side I'm on and the 0 towards the side I'm on, I went backwards instead. So that's going to be my R. And I'm just going to label the 2 there as well. All right, so next we're looking at graphing on an actual polar grid. And I do have some of this polar grid paper for you if you're in class. So first, noticing this is in radians, I'm going to go through and label. This is my 0. This is my pi over 2. Here's my pi. I know I want 5 pi over 6. So it looks like this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So I found 5 pi over 6. So I will go around to 5 pi over 6, and then 3 units. So 1, 2, 3 units would be right here. So you can see this line shows 1 from my pole to that first line is 1, to the second line is 2, to the third line is 3. So that's going to be A. All right, next one is -240 degrees. So -240 means I'm going the other direction now. Negative angles work just like we think they would based on what we've been doing. So this would be my -90, -180, -270. So 240 should be right between those. So let's see, where would 240 be at? 180, this would be, it'd be plus 60 degrees. So I feel like that would be right here. So let's just double check that. 180, and then plus the 30 would be a -210 degrees and a -240 degrees. Yeah. So those are, it's weird to have those double, like every 2 is 30. We're kind of used to making less marks than that on our graphs. So that I would go around to negative 240 degrees, and then negative 2 means though I'm going the opposite direction. So I need to look at this line that it's on and follow that line in the opposite direction, which is going to be over here. And negative 2, negative 1, negative 2 would be right here. So this one's a little bit trickier. And what label? That was supposed to be a Q. All right. Multiple representations of polar coordinates. So this is the one that always really gets people. They want to know lots of different ways to give these names. So the first two are that we're going to go around clockwise and stop there. And the second one is we're going to go counterclockwise and stop there. So that means the first one is 210 degrees. And it looks like if this is my center, this is 1, this is 2. So it should be 2, 210 degrees. And then my second one is to think about that as a negative angle still, but a positive 2. So if I want to think about what that angle would be as a negative angle, I would do 360 minus 210, and that would be 150 degrees. So if I went this direction, this is a negative 150. And this is at 2. We're going to just label this. And this was the 210. So we have 2, 210 or 2, negative 150. So those are two ways that we can label it. Now I'm going to erase because we need to look at what if it was a negative 2 instead. That's going to be the other way to label. So I'm going to go ahead and erase all this. Really, I should have put this down twice because I find it always takes 2 of these. So the other way that we could label it, if we think about this line right here, is we could go to this line and then go negative 2, right? Or we could go around this way to this line and then go a negative 2. So there's the negative 2 ones instead. So we're going to have 2 with the positive 2, 2 with the negative 2. So we could have negative 2 and 30 degrees. Or we could go around backwards to that line and then go negative 2. So the second one will be negative 2, and in order to get that other angle, we need to do 360 minus 30, which is 330. So my other angle is a negative 330 degrees. So if I go clockwise, negative 330 around to this line, and then negative 2. Remember, negative 2 means I'm starting at my pole, I'm going the opposite direction. So I'm not on the side that I'm supposed to be on, I'm on that opposite side. So this is one of the things that really gets people hung up with polar coordinates, is that there's 4 different ways to write these, and we just do not have this in our XY coordinate plane. So I can tell you that we really need to understand right now kind of how this polar grid works. But when we really start doing the tricky math, we're going to be using points like that. So last one is to think about what polar equations look like. And we're going to actually graph an equation. So this is like if I'm on an XY coordinate plane, it's really important that I know how to graph y equals mx plus b. So these are just our kind of basic easy ones that we should be able to graph for polar coordinates. So if my radius is 2.5, that means I always have a radius of 2.5 no matter where I'm at. So here's 1, here's 2, 2.5 would be somewhere in here. So basically what we end up with is like a circle with a 2.5 radius. And that is a really ugly circle, and I apologize for that, but that's going to be like r equals 2.5. So whenever we have a radius equal to something, that is going to be a circle. So it's interesting how easy that circle equation is to write in polar coordinates, or in polar equations. The second one that we're going to graph is just an angle. So if I have an angle 5 pi over 6, so we already figured out that this little graph I'm using counts by 2, pi over 6, 2 pi over 6, this would be 3 pi over 6, 4 pi over 6, 5 pi over 6. So 5 pi over 6 would be this line here. They're not telling me that radius, but I can also extend the line in the other direction. Man, this is just super, super not as neat as I wanted it to be. Let's erase it. So it turns out when we are given an angle like this, it's going to make a line. So that would be that line. So this is, you're just measuring around that 5 pi over 6, and then you're making a whole line for that. Because anywhere on that line would be that angle 5 pi over 6. Last is this polar distance formula. This comes from law of cosine, so it might be kind of familiar. But basically, it's like if I have 2 points and they're in polar coordinates and I want to find the distance between the two of them, then you look at how we have r squared plus the first r squared plus the second r squared. So here's my two r's, right? It's that first coordinate. Minus, we've got 2r1, r2. So again, those are those radii. And then cosine. And then we would subtract the angle. So that's what we're looking at for a polar distance formula. And you might use that on a couple word problems on the homework today. That is it for our 9-1 notes.